Welcome back to the Deep Dive. Today, we're jumping into a really fascinating part of AI. It's about how machines learn when, well, there's no teacher.
Exactly. Hello, everyone. As part of our Dr. AI career notes, I want to pose a question directly to you listening.
Huh?
Can AI actually learn anything useful when there are no right answers provided? No labels?
That's a big question. Usually we think of AI learning from examples, like knowing this is a cat, this isn't.
Right. But imagine you're just given, say, thousands of photos or maybe customer records, and the job is just find the patterns, find the hidden structures. You're not told what structures.
Okay.
Think about it like this. You walk into a new classroom, no teacher yet, no seating chart, nothing. What do you do?
Look around, maybe see who looks friendly or who's into the same stuff.
Exactly. You observe. You might notice, okay, those people over there are all talking about basketball. Or maybe that group seems really into comics.
Right, you sort of naturally find groups.
Yeah, you do. You find common ground, you see patterns, and you start grouping. Well, AI can do something pretty similar. It looks at the data, finds its own patterns, and groups things together, all without any prior labels telling it what's correct.
So that's unsupervised learning, AI figuring it out on its own.
That's the core idea. It's AI on a kind of self-discovery journey with the data.
Okay, so let's contrast that directly with what most people might know, which is supervised learning. You mentioned the cat example.
Yeah, supervised learning is much more structured. You have an input like that cat photo, and you have the correct answer, the label cat.
You feed it tons of labeled examples.
Precisely. It learns the relationship between the input and the correct output, like a student with a textbook and the answer key. They're constantly checking their work against the right answer.
Got it. So unsupervised learning throws out the answer key.
Completely. You only get the input data, no labels. The AI doesn't know this is a cat or this is a dog. Its job is just to look at everything and find, well, commonalities, natural structures, groups that just seem to belong together.
Like your classroom example again. The student's arriving, but the school forgot the class lists.
Exactly that analogy. The students find their own groups, right? The basketball players find each other, the anime fans find each other. These naturally formed groups. That's what unsupervised learning tries to find in the data. It lets the data reveal its own internal organization.
Okay, that makes the difference much clearer. So if there's no teacher, no rules, how does the AI actually do this? How does it find these patterns? What are the methods?
Great question. There are a couple of main techniques we use. The most common one is probably clustering.
Clustering, like grouping things.
Yep, exactly as it sounds. It's about grouping similar data points together into clusters. The AI looks at all the data points and figures out which ones are most alike based on their features.
Without us telling it what alike means beforehand.
Right. It finds those similarities itself. Think about marketing. Businesses have tons of customer data, right? Purchase history, what they browse online, maybe demographics. They can feed all that into a clustering algorithm. The AI might then identify distinct groups. Maybe one cluster is people who always love buying discounted items. Another cluster might be those who prefer to grab new products right when they launch.
So it finds different types of customers automatically.
Yes, and the marketing team didn't have to define those types first. Once the AI finds these clusters, then the marketing team can look at them and say, okay, this group responds well to discount codes. That group wants emails about new arrivals. They can tailor their strategies.
That sounds really powerful for understanding customers. What about other areas? Images, maybe?
Oh, definitely. Imagine you give the AI hundreds of thousands of animal photos, no labels, just pictures.
Okay.
Clustering algorithms might start grouping images that look very similar. Maybe it puts all the furry, four-legged things with pointy ears in one group.
Like cats.
Could be cats. And maybe another group for things with floppy ears and snouts. Maybe dogs. It finds these visual similarities and groups them, potentially separating out dogs, cats, rabbits, all on its own, just based on pixels and shapes.
Wow. So it's like finding categories that exist naturally in the data.
Exactly. It's like going to a party, right? Nobody assigns you to the talk about movies group or the discuss politics group.
No. You just gravitate.
You gravitate. You find your circle. Maybe there's a board game group in the corner, a music discussion near the speakers, a travel chat by the snacks. People form their own groups based on shared interests. AI clustering does the same with data points.
Okay, that analogy really helps. Clustering makes a lot of sense. You mentioned there was a second main method.
Yes, the second one is called dimensionality reduction.
Dimensionality reduction. Sounds a bit more technical.
It sounds technical, but the idea is actually quite intuitive. It's mainly for dealing with Super complex, high-dimensional data.
High-dimensional, meaning lots of features.
Exactly. Data where each item might have hundreds, even thousands of different attributes or features recorded. Think back to that customer database example.
Okay. Age, income, location, browsing history, purchase amount.
What time of day they shop, how many times they clicked on an ad, occupation, preferences, hundreds of things. It's overwhelming for a human to try and see patterns across all those dimensions at once.
Yeah, my brain hurts just thinking about it.
Right. So dimensionality reduction aims to simplify this. It tries to compress all that complexity. It reduces the number of features, the dimensions, but tries its best to keep the most essential information. It highlights the most important factors.
So it's like making a summary.
Yeah.
But for data features.
That's a good way to put it. It takes those hundreds of features and might boil them down to just a few key dimensions that capture the main variations in the data. For instance, it might compress all that customer data into just two main dimensions, maybe one representing spending level and another representing engagement frequency.
So simplifying high-spending frequent buyers versus low-spending occasional browsers.
Precisely. It makes the data much easier for humans to visualize and understand, finding the core structure without getting lost in every tiny detail.
Can you give an analogy for this one too?
Sure. Think about a super detailed roadmap. It shows every single street, every alley, every little park. It's incredibly accurate. But if you just want to figure out how to get across town quickly using the main routes, it's too much information.
Right, you'd probably want a subway map instead.
Exactly. A subway map is a form of dimensionality reduction. It throws out most of the surface streets, the minor features, and just shows you the main subway lines, the most important dimensions, and how they connect. It simplifies the complex city into an easy-to-grasp structure for a specific purpose navigation. Dimensionality reduction does that for complex data.
Okay, I get it now. Simplifying complexity. So we have clustering defined groups and dimensionality reduction to simplify complex data. These sound really useful.
Yeah.
But why should we really care? Why is this whole unsupervised approach becoming so important in AI?
Oh, it's crucial for several big reasons. Three main ones stand out.
All right, let's hear them.
First, and this is a big practical one, cost and time efficiency. Unsupervised learning doesn't require labeled data.
We touched on that. No need for the answer key.
Right. And creating that answer key, that labeling process in supervised learning, that's often the biggest bottleneck. It takes a ton of time and money. Think about medical images.
Yeah.
You need highly trained doctors to sit down and manually label each image, outlining tumors, marking anomalies. It's incredibly labor-intensive and expensive. Unsupervised learning just skips that whole step. It can work with raw data.
So it makes AI potentially usable in areas where getting labeled data is just too hard or costly.
Exactly. It democratizes access to insights from data that might otherwise just sit there unused.
Okay, efficiency. What's the second reason?
The second is about discovery of hidden structures. This is where it gets really interesting. Unsupervised learning can help us uncover hidden patterns that humans might not notice.
Patterns we weren't even looking for.
Precisely. Our brains are good at finding patterns we expect, but we have biases. We might overlook subtle connections in massive data sets. An unsupervised algorithm doesn't have those preconceptions. It might look at customer data and say, hey, wait a minute, there's this group here. Their shopping behavior is really unique and you haven't defined them before.
So it can challenge our assumptions about the data.
Absolutely. And those unexpected discoveries, they often lead to new business opportunities or research directions, things we wouldn't have thought of otherwise. It's like having a fresh pair of eyes, but eyes that can see in thousands of dimensions.
That's pretty cool, finding the unknown unknowns in the data. Okay, reason 3.
Third, it's often used as a pre-processing step for other AI projects. Think of it as a foundational step.
How so?
Well, before you maybe run a supervised learning model, you might first use unsupervised methods like clustering to explore the data and find its approximate structure. You could segment your data into natural groups first.
And then maybe train separate supervised models on each group.
You got it. That can often lead to better results than just throwing one big model at the entire messy data set. It helps organize the data first. It's kind of like students doing some self-study before the formal lesson starts. They might figure out ways to organize the material that helps them learn faster later.
Okay, so it's efficient, it helps discovery, and it can set the stage for other AI tasks. It sounds incredibly useful. But are there downsides? Any tricky parts we need to be aware of? It can't be perfect.
No, definitely not perfect. There are absolutely limitations and challenges. It's important to be realistic.
Such as?
Well, first big one. The results often require human interpretation. The AI finds the clusters or it simplifies the dimensions, but it doesn't tell you what they mean in a business context.
Right, you said that earlier. It finds 3 customer groups, but doesn't name them discount lovers or new product fans.
Exactly. A human analyst still needs to look at the characteristics of the data points within each cluster and figure out, okay, what defines this group? Why are they clustered together? It gives you the what, the structure, but not necessarily the why in plain English.
So human expertise is still very much needed to make sense of it.
Absolutely essential. Second, there's a definite risk of overinterpretation.
Meaning we might see patterns that aren't really there or aren't meaningful.
Yeah. Sometimes the algorithm will group things together, and it might look like a meaningful pattern, but it could just be a coincidence, an artifact of the data noise or how the specific algorithm works.
Like your classroom example, maybe the students grouped by the window just because they like the view, not because they share a deep common interest relevant to, say, teaching.
Exactly. You need to be careful not to read too much into every single pattern the AI finds. You need validation, context. Is this grouping really significant or random-ish?
So it requires careful analysis and validation by humans.
Definitely. Which leads to the idea that unsupervised learning is often best thought of as more like an exploration tool. It's fantastic for exploring data, finding potential structures, generating hypotheses, but it won't directly give you the right answer, like predicting a specific value or classifying something definitively.
It points you in interesting directions, but doesn't give you the final destination map.
That's a great way to put it. It helps you find some possible directions, but you still need to investigate those directions further. It needs a human partner to really unlock its value.
Okay, that provides really important context. It's powerful, but it's a tool for exploration and insight, needing that human layer. What a journey through AI learning without a teacher.
It really is. So, just to wrap up our deep dive today, unsupervised learning lets AI find its own patterns and group itself using raw data. No labels needed.
Which makes it efficient and great for discovering things we didn't expect.
Exactly. Even without that answer key, it unlocks new insights and opens up more possibilities for making sense of all sorts of complex data, from how you market products to maybe even finding subtle clues in medical scans. It lets the data speak for itself.
A fascinating area.
And maybe a little joke to end on. Unsupervised learning is kind of like going to the gym with no plan, no trainer, no workout schedule. But somehow, everyone naturally divides into the treadmill faction and the weightlifting faction.
I can see that. People just find their clusters.
They do. And before we go, just a little teaser for next time. We'll dive into another really cool area. Reinforcement learning.
Oh, reinforcement learning. That sounds interesting, too.
It is. Think of it like raising an electronic pet. The AI learns by trial and error, getting rewards for doing things right and, well, penalties for mistakes.
Learning from consequences.
Exactly. Want to find out how AI is trained step by step to become a master at games or robotics or complex tasks? You won't want to miss the next deep dive.
Definitely sounds like a must listen. Well, thank you for guiding us through the world of unsupervised learning today. And thank you all for joining us on the deep dive. Remember to subscribe so you catch our next exploration into reinforcement learning. We'll see you then.